Okay, in this section, it's going to be section 4.4. We're going to be working with change of base and converting. In your textbook in the back, there's some tables that you can see. This one's for decimal. You got base 10, base 16, base 8, base 2, but base 2 is binary. That might be kind of familiar to you. So it's tables in the back. So there's this one that we're going to refer to later when we're working some problems. And this one as well. So you can see some letters have some number assignments to them, and if you have hexadecimal or binary, you can see some. So some of this stuff will be pulled directly from this table. All right, so let's go back up to the first thing. They're going to give us something that say convert this to base 16. So 3BC base 16. So you go to the base 16 and you look up B and C. So let me go find that real quick. So base 16, B is 11, and C I think we said was 12. So B was 11 and C was 12. So we found that off to the side, just made myself a note. I went to the table, jot that down. And the way you're going to do this is, since it's base 16, and I usually like to write it kind of back to front, you're going to have values, and it's going to be 16 to the 0. In a minute, you'll see this. We're going to have something times 16 to the 0, and then we're going to have 16 to the first power, and there's 3 of them, 1, 2, 3. So we're going to do it 3 times, 16 to the first power, and then we have 16 to the second power, something times 16. So the layout is, when it says base 16, you start with, and we usually start right most. I could have started to the left. It's just easier for me to flow that direction. Start with 16 power 0, 16 power 1, 16 power 2. I have 3 terms up there, 3BC, so I did it 3 times. If I would have 5 terms, I would have kept going to the left, and my next one would have been 16 base 3 times some number, kept plus 16 base 4, some number, so on and so forth. So you'll kind of see this as we continue to do some examples. So in this position, C position, which is to the furthest right, what is the value of C? 12, so we're going to put 12 here. What is the value of B?
11.
In base 16, we'll put 11 here, and then what? And then we just have 3 for our first one. So that's the layout. So in order, you're going to put that value, and if you have to use a table, we went to base 16, we found values for B and C, plug those in, and then now we just calculate.
Are those pluses?
Yes. Yes. Let me make these better. So this is plus. In between each of those is going to be plus. All right. So as we do evaluations of this, this is just 3 times 16 squared is 16 times 16, which is 256. 11 times 16 to the first power is just 16, so that's going to be 11 times 16. And this is anything raised to the 0 power is what? 1. Good. So we plug these in our calculator at 3 times 256 plus 11 times 16 plus 12 times 1. You can put those in and then add them all together. And 3BC is equivalent to 956. 3BC base 16 is equivalent to 956. Okay, we're going to do another one. It says convert 24 base 5 to a value. 24 base 5 to a value. So here's what you do. We're going to, just like before, I have 2 terms and my base is 5. So like I said, I like to start from the back side, and I do 5 base 0 times some value plus, what's my next one? 5 base 1, some value times that. And I do that how many times? 2, because I have 2 terms that I'm working with. So now I'm going to plug in the 4 here and the 2 here. 5 to the first power is just 5, so 2 times 5 is 10. And 4 times 5 to the 0 power is just 1, so 4 times 1 is 4, so this is just 14. So 24 base 5 is equivalent to 14. All right, now we're going to do the opposite. So we took a base of, not of a normal base 10, which is ours, and we converted it to base 16, from base 16 to our number 256 from base 5. Now we're going to go from 8,407 and say, what is that represented in a base 3 format? So now we're going to kind of do the opposite. And this one's the one that's a little more tedious than the other two are pretty easy. Okay, so if you're going to go from 8,407 to base 3, we got to come over here to the side and do some work. 8,407, you leave yourself some room. And we're going to divide that by, what do you think? 3, right? 3, because we're trying to figure out base 3. So let's come over here to the side. This is going to be our scratch work section. 8,407. That goes 0 times, so 0.7. All right, we divide that. What is our remainder? So we had, what we got there was we got 2,802 with a remainder of 1. Okay. Now we're going to divide that number by 3. So 2,802 divided by 3. And that time we get a remainder of 0. So we got 934, but we had a remainder of 0. And we just keep doing this. Now take your 934, divide by 3. Oh, it's not 0, that's 1. There goes the 3. Remainder 1, did you get that? 311, remainder 1. 311. Remainder 1. That time I got remainder 2, so 103, but I had a remainder of 2. $34, remainder 1. Need to write smaller. So 11. 3, remainder 2. One, remainder 0. And then if I did 0 divided by 3, it goes 0 times. Oh, 1. Remainder was 1, not 0. Sorry. So my last one was 1. So 3 goes into 1 0 times. Remainder of 1. So it went 0 times, and my remainder was 1. Okay, so once I get down to 0 over here, you can stop. And then here's where we're going to go from. We will take this and go from bottom up. So it's going to be 1 0 2 1 1 2 1 0 1. Make sure we got 1 0 2 1 1 2 1 0 1, and you would put base 3 underneath it. So basically, you start with the value and divide it into 3s each time, and whatever your remainder is left, we write from the bottom up of that. And this in base 3 represents 8,407. So that's a little bit of work. It's tedious, not that it's really hard. You just have to be careful in doing your division. But it's not that it's crazy hard. So I want you to try the next one on your own. So what do you think we're going to divide by for this one? 6. Divide by 6. So go off to the side, do the calculations, use remainders, and then write from the bottom up. And what's going to be, we'll write base 6 underneath it. So I'll jot this down too as you go, but I want you to try this one on your own. I didn't make any mistakes, I get 1, 1, 1, 1, 3, 4, base 6. So, not that those are very hard, they're just a little time consuming. But this next problem that we have to convert a base 5 to a base 7. So there's two things going on that we're going to have to do here. We're going to have two parts. We're basically going to convert 43 base 5 to a base 10 number to our normal system, and then take that answer and do this to do base 7. So we're going to do like two parts. Basically, it's going to combine both the parts. So 43 base 5. First thing we have to know is, well, what is that value? So we'll take 43 base 5. And we're going to convert it. So there's 1, 2 terms, and we need to go base 5. So 5, 0 is always our first one, and I'm going to add that to a base of 1 multiplied by some number. 5 power 1. So start at 5 to the power of 0, then do 5 to the power 1 and keep moving for however many terms you have. Well, this time we only have 2 terms. So in this case, we have a 3 in this position, we have a 4 in this position, and since we only have 2 terms, that's all we need to do. You do that for as many terms as you have. Okay, so 5 times to the first power is just 5, 5 times 4 is 20, so 20 plus, and 5 to the 0 power is 1, so 3 times 1 is 3, so this value is 23, okay? Well, now that we have value 23, we can now take that and convert it to base 7 using our method that we just used in the previous one. So for our second part of this, we're going to convert 23 to base 7. So if I take 23, what will I divide it by? 7. Good. And keep doing the same process we did just a minute ago. Oops. So I got 3, remainder 2. I'm going to take 3 and then divide that by 7. I got 0, remainder 3. So then we'll have 32, remember, because we go from bottom up, 32 base 7. So that's a 2-step process on this one. If you're given something that's other than base 10, we got to convert it to base 10 first, get that value, and then use this process to convert it to any of the other bases. Okay. Any question on those? All right, so the next type of problem you may see is convert from binary to octal. So binary to octal. And so this one I'm going to have to take some side notes because we have base 2. 2 to the what power gives you 8 to get octal. 2 to the what power? Binary is ones and zeros, but if it's binary, it's 2, and it's to get 8 is what? 2 to the what power? To the third power. Okay, so 2 to the third power gets us 8. So what we're going to be looking for here is groups of 3. I'm just going to make you some side notes over here. So we're going to say start at the right. And break into groups of 3. Okay, so right here, if I was to do that, I'm gonna have 1, 2, 3, 1, 2, 3, 1, 2, 3. Break into groups of 3, so I have 3 different groups there. And then the next thing is convert groups to octal equivalent on the table. So we have our groups, so one group is 100, the next one is 110, and the next one is 111. We need to go to our table, binary to octal, and let's see if we can find that. So you have those numbers on you. So to go from binary to octal, what was our first number? Oh, the first group of 3 was what, 100? So what is that in octal? 4, okay? So put 4 underneath that group of 100. What was 110? Was our second one, so what's that in octal? 6. And then go to 111, which was that. So keep those down on your paper and let me go back up so I can fill that in. So we said that this one was 4, this represents a 6, and this represents a 7, so it's 4, 6, 7. Octal is 8. Base 8. So we went from a base 2 to a base 8. And you have to have the table for that. So the next one, convert from a base 2 to hexadecimal. So if we're going from base 2 to a hexadecimal, the first thing I need to figure out is like, what is my base? Base 2 to something, hexadecimal is 16. So base what? 2 power of what will give me that? 4. So what do you think we make groups of? Groups of 4. Because we're going to convert from base 2 to base 16 basically. And then, so what we got to do there is figure out, well, what's that power equivalent, so we know how to group our values. So if we have the original, I have 1, 0, 1, 1, 0, 1. And you start from the right. Start from the right. 1, 2, 3, 4. 1, 2, 3, 4. Even though they're not there, just go over 4 units. It's just 0, 0, 1, 0. Okay? And then we need to go down and find to the which table? Hexadecimal table, and find out what the values are for 10 and 1101. So let's go there. Hexadecimal to binary, so find the one that matches your conversion, because we're going from base 2, which is binary, to hexadecimal, which is base 16. We look for the first one is 0010, so that's 2. And the other one was what? I don't remember it.
110.
1101, so D. So we have 2 and D. So basically you go to your table, find the conversion that matches, and I think we said 2 and D, so it'd be 2D base 16. Okay, and so the last one is determine the given base 5 numeral representation, one that is divisible by 5. So we want to look at each one of these and say, well, will it be divisible by 5? Do we think it will be? If 3204 base 5, would you think that would be divisible by 5? What if we looked at this units digit? No. Okay, that's not going to be divisible by 5, because if we divide it out, eventually, remember, if we do it the other way, divided by 5, divided by 5, divided by 5, at some point we're still going to have that remainder, so we're going to be no because the unit digit is 4. What about this one? We think of divisible by 5? Yes. What about this one? Yes. And the last one? Divisible by 5? No. So you can look at those bases and see. Like I said, out of all the lessons in this chapter, this one's the one that's probably the more challenging. Not that it's very hard, but it's probably because you haven't done a whole lot of these conversions from different bases. We've been using base 10, and that's what you're most familiar with. And it requires that you'll have to use a textbook chart for that. So, and you'll have that available. So the types of problems we looked at is the ones you convert here. You're given base 16 or a base other than base 10, and you're asked to convert it to that, so we get just to a number. And remember we said if there were more terms here, so say we had something here and something here, we would have 5 of these if there's 5 terms. And you just keep going going towards the left, adding a power to the base each time and multiplying it by whatever that coefficient is up front. Okay, so that was the thing we talked about. If you're going to go from base 10 and you're trying to convert it to a base of a different one, divide it by whatever that base's number is and keep doing that using the remainder to determine your base. And then if they ask you to go from a base other than 10 to another base other than 10, we got to do 2 steps. First convert it to base 10 and then use that same process to get it back to the next base, whichever one you choose, using division and remainders. And then if you're going specific ones from binary to octal or from binary to hexadecimal, you will use the table for that. The only part on you have to figure out here is how to group it. And you group it based on, if you go from binary, which is a base 2, to, you're going to octal, which is 8, you have to figure out what that power is. 2 to the what power would get you 8. Or in the second case, 2 to the what power would get you 16. And then you have to use a table for conversions there. And then sometimes they'll ask you about some divisibility stuff.